Hi all, this video is going to give a formal definition and nomenclature about meta learning. First, we start with supervised learning. So, supervised learning is something as we are interested in a task which has a data set which can be decomposed into training data and the test data. And we are interested to fit a model with parameters theta. And during the training, we are using the training data, and to evaluate its performance, we are using the test data. So objective is to try to fit a model to such to identify the optimal parameters such that loss function is something like error between the true test data and the output of the model data. Model output and the true data is minimized. So this is going to be the loss function is going to be the error between the predictions and the true label. Similarly, meta learning is about similarly we have a bunch of data which is decomposed into training and test data for a single task in a supervised learning. In a meta learning, we have a bunch of tasks, a distribution of tasks which is again segregated into training set of training tasks and set of test tasks. So the set of training task is known as the tau meta train, and set of test data is known as tau meta test. And each task has its own test train data and test data, and the set of task training task uh, data is aggregated as D meta train, and the set of task of test data is aggregated as T meta test data, and each DA has is decomposed into training and test data. The objective is to optimize a model with the find the optimal parameter for a model such that the loss functions across the set of tasks of the training task for the training data is minimized. So this is the meta learning parameter for such that once the model is fit, it's evaluated on the test data on the test task. So this is the concept and which has been demonstrated on the figure 2. So here what we have is training task. The training task has both supportive task and the test task. And here what the training task is bunch of training data for the task 1 and bunch of training data for the task 2, and which has a bunch test data and for the task 1 and test data for the task 2. And this is uh, uh, this is itself a data for the task which is considered to be as a test task, which comes in the category of a test task. So the idea would be to train utilizing this one and try to evaluate its performance using the task on the test. So which we will it might be seems to be a bit confusing. It is something like kind of we try to have a overall we have a different task. That task is divided into training task and test task, and that training task has maybe like a 5 tasks, and each task has its own uh, examples or samples. That samples are utilized and those tasks are utilized to train the model. And once that model is trained across the different tasks in the test training domain, then the test domain has a different set of tasks with a different set of samples which are very limited, and their performance is tested, and if their performance appears to be poor, and that models are fitted based on these loss functions. So these are the nomenclature, which is metric learning based nomenclature, and this is optimization meta learning based nomenclature, and this is training data and test data for, and this is meta training data and meta test data, and this is called a supportive set and query set, and this is training set and test steps. So this nomenclature is for the optimization one, and this nomenclature for the metric based one. Both are same. It's something like we have a set of tasks. The set of tasks is divided into test task and training task, and we have or each task is having own data, and that particular task data is divided into training task and the test task. So that's what is all about this nomenclature and the formal introductions about the meta learning. So the main thing is about we have a bunch of training tasks and a bunch of test tasks, and each training task has own train data and test data, and we are trying to minimize the loss functions across the different tasks in the training domain and try to evaluate in the test domain. Hopefully we'll come out with the next video. We will see about what are the different meta learning algorithms for a few short classification problems. Thank you.